Hey guys! Today we're going to be going over the 2022 AP BC Calculus answers this time, and let's get started into the video. Just a quick reminder that you can access these questions in the official PDF, which I have linked in the description box down below, or you can copy the link in the video shown right now and put it into your search bar. Just another quick reminder that this is not affiliated with the AP College Board. This is just a video going all the answers, which we'll do right now. First is question 3a. This is a non-calculator question, so keep that in mind. So it says let f be a differentiable function, and remember that if it's differentiable, it's also continuous, and then it gives us a starting point, which is f of 4 equals 3, which is very helpful for a start plus accumulation, and then the f prime is the graph shown above. Now we have to find f of 0 and f of 5. Because the graph above is f prime, you must integrate to go back to f, so my f of 0 value will be, and I'm going to be using the start plus accumulation method, so it'll be f of 4, which is my start, and then the integral from my start value, which is 4, to your end value, which is 0, and that's what we're trying to find, of f prime. And now let's actually put some numbers in it. So f of 4 is going to be 3 like it states in the problem. And now we have to integrate the above function from 4 to 0, which is basically the area of a semicircle. Remember that the area of a semicircle is pi r squared divided by 2. And so now our radius will be 2 units long like shown. And so that would be pi and then 2 squared divided by 2, which will be 2 pi. Okay, so that is our area, and so we're done, right? Well, not quite. If you can tell on the graph, the area of the semicircle is below the graph, so the area must be negative. But because we integrated backwards from 4 to 0 and not from 0 to 4, then we have to make the number negative again. Integrating backwards will always result in a negative area, so then it would just be 2 pi. And so our answer for f of 0 is going to be 3 plus 2 pi. And same thing, let's do it for f of 5. So my f of 5 will be the f of 4 plus the integral from my starting value, or at 4, and then my end value, which I'm trying to find, is going to be 5 of f prime. And so from 4 to 5, we are not integrating backwards or anything, so we don't have to make it positive or negative or whatever. And so f of 5 will equal f of 4, which is 3, plus, and then on the graph, we need to find the area from 4 to 5, which is half. And so that would be your answer to f of 5. And for the points, I think it'll be a point for finding f of 0 and then another for finding f of 5. Now on to question 3b. We have to find the x-coordinates of the points of inflection. Remember that points of inflection always come from the second derivative, but we're given the graph of the first derivative, f prime. So we must look at the slopes of f prime to find the values of f double prime. And then we have to find when the slopes are changing sign, because by definition, that is what a point of inflection is. So I'm going to be using an f double prime number line to do this. And I'm going to start off by putting points when the slopes are changing sign and also at the endpoints. Don't forget the endpoints. So 0 is an endpoint, so I'm going to place that down. And at x equals 2, the slope changes from negative to positive, so I can put that down. At x equals 4, there might be something going on there, and just to be on the safe side, I'm going to place x equals 4. And at x equals 6, as well as x equals 7, because again, it is also an endpoint, which we must consider. Now, with these numbers on the number line, we must look at slopes next. So the slope from 0 to 2 is going to be negative, so I'm just going to place a negative from that little interval. And then the slope from 2 to 4 is positive. The slope from 4 to 6 is also positive. And the slope from 6 to 7 is negative. So now our points of inflection will be when the slope changes sign. It changes sign at x equals 2 and at x equals 6. So now our points of inflection will be at x equals 2 and x equals 6 as your final answer. Now remember that a number line will not be enough justification, and it does say to justify your answer. So you have to explain in a sentence on why it's correct. So a good sentence for a justification would be that the points of inflection are at x equals 2 and 6 because the slope changes sign, and that's pretty much good for your justification. And now I'm thinking for the points, that it's going to be a point for finding x equals 2 and x equals 6, and then another point for finding the correct justification on y. Okay, now on to question 3c. It says, let g be the function defined by g of x equals f of x minus x. Okay, and then g is decreasing. Okay, and then it also asks if g is decreasing in the interval of 0 to 7. And now we have to find when g is decreasing. And when we're trying to find if something is increasing or decreasing, we always have to look at the first derivative, or f prime of x. So what they give us in the problem is g of x and f of x, so we must differentiate to find f prime of x. So my g prime of x is going to equal the derivative of f of x, which is f prime of x, and the derivative of x is just 1. Now, because it's asking for when g is decreasing, that means the value must be less than 0. So I'm actually going to write down g prime of x is less than 0, and this statement is only true if and only if f prime of x minus 1 is also less than 0, because we already set them equal to each other. So I can just move the 1 over, and then my new inequality will be that f prime of x is less than 1. So when is f prime of x less than 1? Well, thankfully, we're given a graph of f prime, and now we have to find the points that intersect the line, which is at x equals 5 and at x equals 7. So now remember that we needed to find when g is decreasing, which means that it is below the line. So the part of the graph below the line is this part, and so that would be from 0 to 5. And now the intervals where g is decreasing or below the line is at 0, 5, or when x is between 0 and 5. You can write it either way, doesn't really matter. Just make sure that you do not put any brackets or any equal signs, because it's increasing and decreasing, so there can't be an equal to that value. So now for the points, I think it's going to be a point for finding that derivative of g of x, and also finding all those x values, and another for finding the correct interval. Now, our last part, which is question 3D, we need to find the absolute minimum, and that can be found using the candidate test. And it says that we need to use the function g from part C, which for reference is the g of x equals f of x minus x. Now, for the candidate test, we also need to find the derivative of our function and set that to 0. So our derivative of g of x, which we also found in part C, is right here. And we need to set g prime of x to 0 to find the critical numbers. And remember that f prime of x is equal to 1 when you set it to 0. And our x values were 5 and 7, which we found from the last problem. And we also need to accommodate endpoints, so make sure to include the 0 as well. Now let's do a quick table and find out all our values using our candidate test. So we have g of 0, g of 5, and then g of 7. So placing in 0 into the function, f of 0, if you remember, was found in part A, which was 3 plus 2 pi, and then we have to minus the 0 as well. For g of 5, just plug in 5 into the equation, and for f of 5, we already found, which we found in part A. It's actually pretty common to find answers in other problems, so be sure to look out for that when you take the test. Now, our f of 5 from the last problem was 3 plus half, and then we also have the minus 5. And then for g of 7, it is not given. We did not find it yet, so we actually do need to do a little bit of extra work, which is totally fine. And so our f of 7 is going to be found using our start plus accumulation like we did in part A. And so to find that, we're going to have our f of 4 plus the integral from our start value, which is at 4, to our end value of 7, and that will be of f prime. And so we need to find the area from 4 to 7. And I already found that out, which is going to be 3.5. So our f of 7 is going to be f of 4, which is 3, plus the area from 4 to 7, which is 3.5. And then, of course, we can't forget the minus 7, so it's going to be 3 plus 3.5 minus 7. Now let's find all the values to see which really is the absolute minimum. So 3 plus 2 pi is 9.283, and then 3 plus 0.5 minus 5 is going to be negative 1.5, and last but not least, 3 plus 3.5 minus 7 is negative 0.5. And so remember that in this question you don't get a calculator, so you can tell from g of 0 that it's pretty much going to be all positive, whereas g of 5 and g of 7 it's going to be negative, so you don't really need to find the value of g of 0 since it's positive. And then for g of 5 and g of 7 it's pretty simple math. Okay, and now for the absolute minimum, it's going to be the smallest value. So our smallest value of all three is the negative 1.5, and our answer will be that the absolute minimum at x equals 5 is negative 1.5. Now, for the points, I think it's going to be a point for finding g of 0 and g of 5, just because it was relatively simple because we already did that in part A. And then I think it's going to be another point for finding g of 7 since we did have to do a little bit more work to get there. And then, of course, the last point is going to be having the correct answer. And that is the end of FRQ 3. Now let's go ahead and do some score predictions. So these are my own predictions of what you might need to get at least a 3, and then my score predictions for a 4 or a 5. Now again, these are not the official scores that you need to get, but I've kind of formulated my own looking at past ones. And also a quick update that the AP College Board, Trevor Packer, is actually revealing some score distributions right now. They usually do so like 2 weeks prior to the release date, but there's 9 more days until scores come out, which is July 5th. Kind of nervous. And so if you go onto Trevor Packer's Twitter, you can see all the percentages of the amount of people who got which score. So far, they haven't released any calculus ones yet, but stay tuned. He should be doing it sometime this week. And here are just some score stats for some other tests if you took the AP Chemistry test or the AP Human Geography test. He's posted a little bit more, so be sure to check periodically throughout the day if you want to see any other AP tests. And thank you for watching my video. Be sure to give this video a huge thumbs up, subscribe if you learned something new, and comment if you have any questions. Also, if you took the AP Language test and want to know some answers, then check out the video to the left. If you want to know the answers to FRQ number 2 for the BC Calculus test, then you can click on the video to the right. Thank you so much for watching, and be sure to stay tuned for my upcoming